Assalamu alaikum. Right, today we've got a question on circle theorems. And this question reads as such: P, Q, R, and S are some points on the circumference of a circle with center O. So let's have a look at that. So that's the point P, Q, R, and S, and they're on the circumference, which is the outside or the outline of the circle. If you imagine the circle being like a pizza, so the circumference would be the crust of the pizza. Okay, so PQRS are points on the circumference of the circle. Center O. If O is the center, that means OQ is a radius and OP is a radius. Alright, and remember, I told you should start having conversations with the diagram. So if OP is a radius and OQ is a radius, you see this line APB, it touches the circle at only one point, which is the point P. So APB must be a tangent, and so should ASD, and so should BQC. These are tangents because they're touching the circumference of the circle at only one point, and DRC as well. Okay, so we've got all of these points. They're all, it tells us over here they're tangents to the circle. Right, ABCD is also a kite, so that is this shape here. ABCD is a kite. An angle PAS is 2x. Angle PAS is 2x, so this one here. An angle QCR is y, that's that angle there. Find an expression in terms of x and y for the sides in degrees for the angle POQ. Alright, let's get started. This is a very nice and interesting question. Okay, so firstly we need to know some properties of a kite. A kite is a quadrilateral, a four-sided shape where you have two pairs of adjacent sides that are equal. Adjacent means right next to each other. So the side AB will be equal to the side AD. Similarly, the side DC will be equal to the side BC. Also, another property of a kite is one pair of adjacent angles are equal. So angle ADC will be equal to angle ABC. And let's write that down. Angle ADC is equal to angle ABC. And I'm going to try and fit all the working out in this page, but it is quite a lot. So let's start off one pair, and the reason is one pair of adjacent angles can I fit it in? Adjacent angles in a kite are equal. Okay, so I found that these two angles are equal. Now if you look at ABCD, which is a kite, right, the sum of all the angles would be 360 degrees because it's a quadrilateral. So angle ADC plus angle ABC. Now where's ADC? ADC is the one at the bottom here, and ABC are over there. Sorry, plus angle BAD and plus angle BCD. So plus angle BAD bad plus angle BCD, where's BCD, is equal to 360 degrees. I'm going to write this reason just above. I've got some space here, so I'm going to utilize it. The reason is angles in a quadrilateral quadrilateral. Add up to 360 degrees. So because it wants all the reasons, we have to give them. So ADC and ABC are the same, so I can call it I'm dealing with okay, I'm gonna use ABC. So ADC is the same as ABC, so I'm gonna substitute ADC with ABC here, plus another angle ABC. I'm gonna leave that as it is, plus angle BAD. What's BAD? It's 2x, plus angle BCD. Where's BCD? It's y, is equal to 360 degrees. So I can say 2 lots of angle ABC plus 2x plus y is equal to 360 degrees. So what I'm gonna do, just to save on space, I'm gonna subtract 2x both sides, and then I'm gonna subtract y also on both sides because I want ABC on its own. So just to save space, I've done both of them together. So I've got 2 angle ABC is equal to 360 degrees minus 2x minus y, and then I divide both sides by 2 to get angle ABC. So angle ABC is equal to, well, when I divide this, I can write it as 360 over 2 minus, oh, I need to put this in brackets by the way, 2x minus y oh no, I don't need to put in brackets, sorry. Okay, if I was to put it in brackets, I would have to change this to a plus. And the reason for that is when I expand it, it would be minus 2x plus minus y, sorry. So anyway, I can skip the bracket step. If I want, I can keep it as one fraction, or just to avoid confusion, I can do 360 divided by 2, which is 180 degrees, minus 2x minus y over 2. All of this is divided by 2. Okay, that's angle ABC. Now if we look at this shape here, let's choose green. PB, BQ, OQ, and PO. Alright, let's look at that. Now BP is equal to BQ, and we're going to use a circle theorem for this, and the circle theorem is tangents drawn from the same point, both of these are tangents drawn from B, are equal. Okay, and then PO is equal to PQ. PO is equal to, sorry, PO is equal to OQ, not PQ, my mistake. Right, PO is equal to OQ, and that is the reason for this is PO and OQ are radii of the circle. So one radius, many radii, singular and plural. Of the circle. So this would mean that actually in this shape here, PB is equal to BQ and PO is equal to OQ. So these two sides are adjacent to each other and these two sides are adjacent to each other. So you got two pairs of adjacent sides equal to each other. So OPBQ. So OPBQ is a kite. Because, can I fit this in? It has two pairs, has two pairs of adjacent side equal. Okay, done that. So I know now that OPBQ is a kite. Now in addition to that, if I notice that this is a radius and that's a tangent, so radius and tangent meet in 90 degrees. That's another circle theorem, right? So let's state that. This is okay, and that I've got from here, because angle ABC is the same as angle PBQ. Anyway, where was I? Alright, radius and tangent meet in 90 degrees. So angle OPB, where can I fit this? Right, let's try this. Angle OPB is equal to angle OQB is equal to 90 degrees, and the reason for this is the radius and tangent meet at 90 degrees. Okay, right. So now in the kite OPBQ, it's a quadrilateral, so all four angles will add up to 360 degrees. All I need to do is find the size of this one, so I can say angle POQ is equal to 360 degrees minus, and in a whole pair of brackets I'm gonna have 90 and that 90 degrees is from here plus another 90, and that is going to be from here plus 180 minus 2x minus 2y over 2. Sorry, minus 2x minus y over 2, not 2y. Okay, and that I get from the top angle over here. Okay, and there's a reason for this, and the reason is angles in a quadrilateral, so small, I'm trying to fit this in, add up to 360 degrees. Okay, there we go. Now I need to simplify this bracket. Let's go back to blue. So that will be equal to 360 degrees. When I add these up, 90 and 90 is 180, and 180 at 180 is 360. So I'm going to open the bracket up, minus 360 degrees, and it'll become plus 2x. Let me just move this out of the way. Plus 2x plus y over 2. Because of this minus, all the signs will change. So that's angle POQ. So the 360 and degrees cancels out with the other 360 degrees. So in the end, you get angle POQ is equal to 2x plus y over 2. And that is it. Just about fit it in. Completely ran out of space on this one. Okay. It's a pretty lengthy question. It's taken quite a while to explain it, but I believe I've gone through every single step and explained every single reason. So it looks complicated. It's a very enjoyable question, and it requires a good amount of knowledge of the circle theorems. So I hope this helps, and thank you for watching this video. In the description, I'm leaving a link for these packs, for the foundation ones and the higher ones. So the foundation videos have the foundation packs, and the higher videos have the higher packs. You can download these packs and try some of the questions. The answers should be there as well from the mark schemes at the end. Have a go at these questions, and I'll try and do as many of these as possible and upload some videos just to see how to solve them. Okay, thank you for watching, and all the best with your revision.